Hello, and welcome to Unit 5, Lesson 3 on solving systems of linear equations by elimination. Please take this time to write your name, date, and period on this paper, just like we usually do. And I will make it clear that in this video lesson, you will not need a ruler. Okay? So before we begin with our new lesson, let's just briefly talk about where we are. So the first method that we learned in solving systems was graphing. So we mostly use slope-intercept form, y equals mx plus b, to help us graph. And then the second one was the substitution. In substitution, we either had x equal to or y equal to and substituted in. Now the third one, which will be the last technique that you'll learn in solving system, is called elimination. Now, this technique, you want to use it when you have two equations that are written in standard form. Remember, standard form is ax plus by is equal to c. That's when you have all the variables on one side and the constant c is on the other. And I've shown you in the example, if you have two standard form equations, then this tells you that you have to use elimination method. And it makes sense to use this because other techniques like graphing and substitution are a little more work. So I'm going to talk to you about the steps of solving system by elimination. What I'm about to tell you might sound like a bunch of nonsense until you actually see what it means. But just play along with me and I promise you that I will explain as we go through. So the first step is to align like terms. Align means you line them up. So for example, if you have 4x plus 3y is equal to 8, and you have 2x, what's another one, minus 2y is equal to 4. This is already aligned. This is already done because a line-like term means if you have x here, on the bottom you should also have x. And if you have y's, then you also should have y's together, y's lined up, and then the number, the constants lined up. That's what it means to align like terms. Terms that look similar has to be on top of each other. You have to line them up. And then the next step is to make equations have the same opposite coefficients by multiplying. And that is only if it's necessary. Meaning that this step 2, sometimes you don't need it. Sometimes you don't need it, but sometimes you do. And you should multiply to have them just have same opposite coefficients. So for example, if you look at the top one, 4x plus 3y is equal to 8. And I have 2x minus, I will say 3y is equal to 6. Actually, I'm going to change that. That's not a good example. How about I make this 4? Now, coefficients are the numbers in front of variables. So here you have 4x and 2x, so the coefficients are 4 and 2. In front of the y's, you have 3 and negative 4. If I have to make the same opposite coefficient, it's like 3 and negative 3. Or 4, negative 3, the same number but opposite signs. So if you see here, 4 and 2 are not opposite, 3 and negative 4 are not opposite. So you have to make them, and how we do that is by multiplying. This is positive 4. So if I want to make that negative 4, because I need to have the same opposite coefficients, I'm going to multiply everything here by negative 2. Then what I will get, I'll work backwards. The first equation is 4x plus 3y equals 8. Stays the same. But then the bottom one, I got to distribute now. I'm going to multiply everything by negative 2. So I'm going to get negative 4x Then negative 2 times negative 4y is positive 8y plus 8y equals negative 2 times 6, which is negative 12. And now if you can see, this is 4 here, and this is negative 4. These are opposite coefficients. Now you don't have to make everything opposite coefficient as long as either x or y, just one pair, just one of them, if you make them same opposite coefficients, it's fine. You could have changed the coefficients in front of y. That's fine too. Okay, but you do that by multiplying. Now the third step, this is something that you will always need. You always will need it. And I'm actually going to put a star on step 3. For elimination method, you will always need it. And that is to eliminate one variable by adding and solve for the other variable. So as you remember, this is called an elimination method. And in step 3, it tells you to eliminate, and you do that by adding them. So for example, from the previous step, I showed you an example problem where we had negative 4x plus 3y equals 8. And then we changed the second equation by multiplying negative 2 and made it to negative 4x plus 8y is equal to negative 12. Now, what this is telling us is for us to change this. Well, I'm sorry, that should have been positive 4x. So it should be positive 4x up here. And then step 3, once you're here, you have to add them. And if you add, what's going to happen is you're going to eliminate one, meaning you're going to get rid of it. 4x, positive 4x minus 4x. 4 minus 4, it's a 0 pair, so these cancels out. We just eliminated x. We eliminated by adding. So then you solve for the rest, which is 8y plus 3y, which is 11y, equals 8 plus negative 12, which is negative 4. Then you get 11y equals negative 4. So then you would just divide both sides by 11 and solve for y, which is negative 4 over 11. You just solve for one variable. I only found y. Then the next step is to substitute answer from step 3 into one of the original equations and solve for the other missing variable. So what it means is that whatever you found here, and we found y equals negative 4 over 3, you're going to substitute, put that in one of the equations, but it has to be in the way it was before. So it doesn't matter which equation you use. You can pick anything you want. And like we learned from the substitution method, you want to pick the easier equation. And I'm going to go with the positive one. So if you have 4x plus 3y equals 8, let's say I'm going with the first equation, I'm going to put that y and the y here. So you would have 4x plus 3, and then instead of y, you're going to put negative 4 over 11 equals 8. And if you do that, eventually, boom, 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 you're going to get x equal something. You're going to get another number. So then you will find y, and then you will find x. Then the last step is to write your answer as an order pair. So whatever answer you get for y value and x value, you're going to put them in a parenthesis with comma in the middle, x comma y, and that will be your solution. And like I said, I know it might sound very like a bunch of nonsense to you, but as we look over the example problems and go through each step, you will become familiar with it, okay? All right, so since that's the end of all the steps, let's see what it all means. So we're going to look at example 1. We're going to look at part A first. We have this system right here, and it's telling us to solve it by using elimination method. So that means if you're solving, you need to find what x value and y value are. Now I'm going to name this as the first equation and second equation. So that's how I'm going to call them, okay? So if you have your notes in front of you, remember all the steps we wrote down, we can look at them too. You can go to your steps that's on your notes, refer to it as we do each steps of the problem, okay? But you can also look here, and you don't have to write all the step descriptions that I write, okay? It's your choice, it's your notes, so however you want to have it in your notes, just write it there, but you don't have to make it look exactly like mine. So if you look at our steps, the first step is to align our equations, align like terms. And if you look at it, x is with x, y with y, constant with constant. So the first step is already done for you. It's done. And then the next one, second step is to multiply to make the same opposite coefficients. And actually don't need to do this either, because if you look at the coefficients of the y, the one is positive 3 and the other one is negative 3. So this step 2, was also already done for me in this example. Again, if you want to circle it to make sure, that's fine. But here, these are same opposite coefficient, positive 3 and negative 3. So I don't need to do step 2. It's already done. Good. Now, let's move on to the next step. I have to go straight to step 3, which is to just add, to eliminate, and solve. So I'm just going to add these two equations. And let's see how that happens. So if I have x plus 3y is equal to negative 2, x minus 3y is equal to 16. I'm going to just line them up and add them one at a time. So x plus x is 2x. Positive 3y plus 3y, remember, we wanted to eliminate them. These are opposites, so these are gone. Equal to negative 2 plus 16, which is 14. And if I divide both sides by 2, x is equal to 7. So we already solved for one variable. We eliminated the y, so we found x. And then the step 4 is to use answer from step 3. So we said x is equal to 7. We're going to use that to find our y value. So step 4 is to substitute x equals 7 to find y. And when we're substituting, like we learned from substitution method, it doesn't matter which equation you choose. Whatever looks easier to you, just pick that one. And I'm actually going to pick the first equation because it has positive. And I'm going to use that to plug it in. So if I have x plus 3y is equal to negative 2, since I'm substituting x equals 7 here, it will become 7 plus 3y equals negative 2. Then solve for y, subtract 7 both sides. You should be familiar with these steps now. 3y is equal to negative 9. Divide both sides by 3. And I have that y is equal to negative 3. Boom. So if I were writing my answer as order pair, which is our last step, it will be 7, comma, negative 3. However, you want to make sure that you have the right answer. So I'm going to actually have to plug it in and check to see if I have the right answers. Okay? So I'm going to plug in my solution into one of the equations, both the equations, to make sure that this is correct. So if I have x plus 3y is negative 2, x plus 3y equals negative 2. Then x is 7, so 7 plus 3 times y is negative 3 equals negative 2. Let's see if this is true. 7 plus 3 times negative 3 is negative 9 equals -2. 7 plus -9 is -2, and -2 is equal to -2, which is true, so check. That's correct. Our solution, it works in the first equation. And you have to check with the second one. If you have x, now the 3y is equal to 16. X is 7, so 7 minus 3, then y is -3 times -3 equals 16. So then, I'm sorry, it looks messy here, but then I have 7. And this is -3 times -3, which is 9. So plus 9 equals 16. And is that true? Yes, 7 plus 9 is 16, and that's equal to 16, so it's correct. The solution, 7 comma -3, works in both equations, so that must be the correct answer. This means that that's the point where the two equations intersect. If you graph it, they're going to intersect right at 7 comma -3. That's the point of intersection, and that's our solution. All right, so let's check out another one, example part B. So we got this system, and if you look at the equations, okay, x is together, y is together, constants together. So the first step is already done for us. It's already aligned. Perfect. Now the second is always to multiply to make the same opposite coefficients. Let's see if we have same opposite coefficients, and let's see if we have to multiply or not. So here is -6 and -2. They're not opposite coefficients. This is +5, -4. They are not the same opposite coefficients. So how are we going to make these two same opposites, or these two same opposites? And whenever you are in this kind of situation, you have to figure out which one you want to change. This is 5 and 4. So remember when we have least common multiple, if you have, let's say, 3 and 4, the common multiple, it would be 12. If you have 6 and, let's see, 2, then the common multiple is 6. What is the multiple that they have in common? Right, and this is the same idea. Which one are you going to, let's start with the one you want to pick. Do you want to pick with these two coefficients or these two? And I'm actually going to stay with x. I'm going to change -6 and -2, but I don't have to change both of them. I can just multiply the second equation by -3, because if I do -3 times -2, it will be +6. And -6 plus and +6 are same opposites. So that works. So I'm going to multiply the second equation by -3, and that will give me that first equation stays the same, -6x plus 5y equals 25. And then -3 times -2x, and put it in a different color, would be 6x. And -3 times -4y is plus 12y equals -3 times 14, which is -42. Now, when I multiply, I have this parentheses around the entire equation. And the reason why I do that is that I'm multiplying -3 into both sides. I'm multiplying -3 to the left side and the right side. And by doing this, it's reminding me to multiply everything by -3. And if I do that, the second equation turns into this purple one. And if you look at the first coefficients in front of x, you have -6 and +6, which are the same opposite coefficients. So perfect, it worked. Now the third step, I can finally add them and solve. So I just rewrote what I had up there, and these two equations, I just rewrote it, and now I'm adding them. And again, you don't have to do it, write your notes the way it looks here. You can, if you don't want to, you can just add them here. If you don't want to, you don't have to write this. Just make your notes your own. Again, I'm going to add them. And if I add negative 6x plus 6x is 0, so I eliminate it. 5x plus 12y will be, 5y plus 12y is 17y equals 25 plus negative 42 is negative 17. Then if I divide both sides by 17, cancels out, I have y is equal to negative 1. So I have half of my answer, and the y value is negative 1. So this is an example where you have to do step 2. So keep this in mind. In part A, you didn't have to multiply. In part 2, you have to because you don't have any same opposite coefficients. And I multiply the second equation by negative 3 to make this positive 6. So that when I add negative 6 and positive 6, they're eliminated. And like I said, you don't have to eliminate x. You can eliminate y first. Now we're moving on to step 4 because we found our y value. Our y value is negative 1. And for step 4, we're going to substitute y equals negative 1 into one of the original equations and find x value. So when you substitute, let's see which equation is easier, the first one or the second one. I'm going to go with the first one because it has plus. I don't want any more negatives. So I'm going to plug it into the first equation. So then I have negative 6x plus 5y is equal to 25, but we're going to substitute y as negative 1. Then we'll have negative 6x. 5 times negative 1 is minus 5. Negative 5 equals 25. Then add 5 both sides. I will have that negative 6x is equal to 25 plus 5, which is 30. Divide both sides by negative 6. Then x will be equal to negative 5. 30 divided by negative 6 is negative 5. So I found the other half of my answer, negative 5. And so far my solution is negative 5 comma negative 1. Now, like I said before, we're not done yet. We're going to have to check our answer. And we do that by plugging the answer into both of these equations. So I have negative 6x plus 5y is equal to 25 as a first equation. And I'm going to plug it into the original second one, negative 2x minus 4y equals 14. But x is negative 5, so this is going to be negative 6 times negative 5 plus 5 times negative 1 equals 25. Negative 6 times negative 5 is positive 30. 5 times negative 1 is negative 5. So I'm going to just put negative 5 equals 25. And let's see if this is true. 30 minus 5 is 25. And that is equal to 25. So that works. The answer fits in the first equation. Now the second equation will be negative 2 times negative 5. The minus 4 times negative 1 equals 14. Let's see if this is true. Negative 2 times negative 5 is positive 10. And then negative 4 times negative 1 is positive 4 equals 14. And 10 plus 4 is 14. And that's equal to 14. So this is also true. So our answer, negative 5 comma negative 1, is the correct solution. And again, if you were graphing these two equations, that means the point of intersection will be negative 5 comma -1. Perfect. All right, so this is the end of our first video lesson for Unit 5, Lesson 3. It was a long one. I know, if you want to take a little short break before you move on to the next video, that's fine. But if you have any questions, please remember to ask the teacher or write them down. And remember, when you're writing down these notes, you don't have to write them exactly the way it looks here, because I know this is a lot, and I put extra notes here. If you want to make it look more organized, or if you have a better idea to organize the notes here, you may do so. Any extra notes will give you extra credits. All right, so I'll see you in the next video lesson.